go. All right. Make sure that is straight. Okay. Good evening. Hello, hello. All right. So, good evening. Usually I'm here on in the afternoon, but had so many tech issues I had to wait until this evening. So, my name is Jewel Martin. I am the CEO and instructor of Jumpstart with Jewel. We offer tutoring and educational services for adolescents and adults. And we also assist students that have ADHD, that have autism, any type of special needs. We cater to their needs to help them to be successful as well. So welcome to today's broadcast. Again, my name is Jewel Martin, and I'm usually on here in the afternoon, but we were having some tech issues, so I decided to still go ahead and live stream this evening. So I hope everyone is doing well. Over the past few weeks, we've been working with fractions, and we do have a class that is starting next week. It is a class that's all about fractions. Becoming fantastic with fractions is the group class. It's a small group online class. The class starts next Tuesday on the 24th. It is a class, small group, online through Zoom. Classes will be recorded. There are 8 sessions in all. Classes start at 4 o'clock Eastern Standard Time. So if you have a child, a grandchild, godchild that needs assistance with fractions, we'll be going over several topics such as equivalent fractions, simplifying fractions, adding or subtracting fractions, and so much more. You can go to the website at www.jumpstartwithjewel.com for more information or to sign up. You can do one payment, or you can do 4 weekly payments to your convenience. So today, what we're going to review are the greatest common factors, finding the greatest common factors of 3 numbers. This, for some students, can be a little challenging. Sometimes when you're finding the greatest common factors, it can be of 2 numbers, but when it becomes 3 numbers, it becomes a little more tricky, okay? So there's a few ways to find the greatest common factors, but there's usually 2 ways to do them best. The first way is to list them. Now, depending on what the number is, it may take you a little while to list them, but that's usually the first choice that everyone does, is to list them. The other way is to do a factor tree. So I'm going to show you how to do the first one. Let me move this screen over. Make it larger. Here we go. So the first thing we're going to do, let me just put it here. We're going to find the GCF of these 3 numbers of, let's see, 24, 32, and 36. Okay. So the first thing you can do is list them. So the factors of 24. And if you don't know your multiplication facts by heart yet, you may want to use a multiplication table if you can, to assist you while you're still learning your facts. So the factors of 24, it's always going to be 1. 24 is an even number, so one of the factors of 24 is always going to be 2. A factor of any even number is always going to be 2. If you know your facts, you know that 3 is also a factor of 24, as well as 4. So when you think about your multiplication facts, 6 is also a factor, because 4 times 6 is 24. We've got our 3 there. 3 times 8 is 24, so 8's a factor. Also, when you think of 2 is the even number. 2 times 12 equals 24, and we've got a 1 there. 1 times 24 is a factor of 24. Sometimes what I'll tell my students to do is to list them in order in numerical order like I have there, so that way it makes more sense, okay? So now we have the factors of 32. So same thing, of course, it's going to be 1, and we'll add 32 in a minute. 1 and 32, it's an even number, so it's going to be 2. 2 times 16 equals 32, so that's a factor as well. 4, if you know your multiplication facts, what number times 4 equals 32? That's 8. And then again, like we said, we have 16, because 16 times 2 is 32. And then 32 times 1 is 32. And then the last one, I need to spell, it's 36. So of course 1, 2 is a factor because 2 is an even number. 3 is a factor of 36. Also 4. 36 has a lot of factors. 4, 6. Remember, 6 times 6 is 36. We have a 3 there. What number, when you multiply it times 3, gives you 36? That's 12. Also 9. 9 times 4 is 36. 12 times 3 is 36. As well as, did I miss one? Yep, 18. 18 times 2 is 36. And last but not least is 36 times 1. So those are all the factors of 24, 32, and 36. So when you're looking at this and you're trying to find the greatest common factor, the greatest common factor is the largest factor that is shared between these three numbers. Hello there on Periscope. How are you? So those are the factors. So when you look at the factors, what number do they have in common? That they all have in common. And what is the largest one? Because they're all even numbers. They all have a 2 as a common factor, but 2 isn't the largest one. The largest one is actually going to be the 4. Let me get my pen ready. They all have a 4 in common. And I'm sorry if you're saying something to me on Periscope, for whatever reason, it won't let me see the comments. I apologize if you're saying something. I can't even see it right now. I'm sorry. So 4 is the greatest common factor of 24, 32, and 36 if you want to list them. If you don't want to list them, the other way to do it is a factor tree. When you have a factor tree, it makes it easier, especially if you have to list the factors of larger numbers. Because if you have larger numbers, you'll be listing and going on and on and on. So we have a factor tree. You write your numbers. We got 24, 32, and 36. Down a little bit. So the first one is 24. When you're doing factoring trees rather, I usually do it, the best way to do it is to think of give the largest number and the smallest number. If you think about 24, we have the list of factors up here. You see them all here. I would put 2 and 12. 2 is a prime number, meaning when you have a prime number, that means that the only factors of that number are 1 in itself. There's nothing else after that 2. 2 is a prime number. So if I had put 2 and 12, then I get to break down what are the factors of 12. And of course, when you're using a factor tree, you can't use the number and the number 1. You can't use itself and 1. You have to think of some of the other factors. So in the one example I did 2 and 6. Now in some cases you'll see them where they'll circle the prime number. 2 can't be broken down any further. 2 is as low as it'll go. 2 is also a prime number. 6 is not prime because it has 2 factors that you can use for 6. What 2 numbers, when you multiply them together, give you 6? 3 and 2. Once you're doing a factor tree, and you have it down to the lowest prime number, it can't go any further. So you're done with this. So we have all our prime numbers. We've got a 2, a 2, a 3, and a 2. And if you were to multiply these numbers together, all these prime numbers together, it would give you 24. Now let's go to 32. So same thing here. I've got my factors listed of 32. So I'll do 2 and 16. 2 is a prime number. So I'm going to circle that. I can't break that down any further. Let's look at 16. What are the factors of 16? 2 and 8. 2 is my prime number, so I'm going to circle it. Then I've got 8. I can continue to break 8 down. 8 is not a prime number. It's a composite number. It has 2 more factors to it. The factors of 8. What 2 numbers do you multiply together to give you 8? 4 and 2. Actually, I'm going to flip it around. I'll put 2 here and 4. 2 is prime, and then here I've got 4. I can still break that down. 2 and 2. So I've got nothing but prime numbers. And again, if I took all these prime numbers that I circled 2 and multiplied them together, 2 times 2 times 2 times 2 times 2, I would get 32. Now I've got 36. So again, think about 36, of course, is an even number. One of the factors, what number is a factor of every even number? 2. 2 is a factor of every even number that you could possibly have, whether it be 20 or whether it be 2,520. 2 is always going to be one of the factors. So we've got 2, we've got 18. 2 is my prime number. I can circle that. What 2 numbers do you multiply together to give you 18? 9 and 2. Okay, I'll flip that around again so that all my prime numbers are on the same side. 2 and 9. Circle 2. Okay, we've got 9. What 2 numbers do you multiply together to give you 9? 3 and 3. 3's are prime numbers. The only factors that 3 has are 1 and itself. Okay, so, oops, something moved. I don't know if it moved over there. For some reason, it jumped on my screen. Let me undo that. Okay. I don't know if it jumped on the screen or not. So, I have my factors here. I've got these 2's. I've got 3's. 2's here. I've got 2's and 3's here. So, in order to find out the GCF, what you want to do, what you could do when you're doing a factor tree, write down all the numbers. All the prime numbers. 2 times 2 times 3 times 2. So I'm writing down all the prime numbers that I have for 24. 2, 2, 3, and 2. If you were to multiply these all up, like I said, you would get 24. 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24. If I list 32, I'm running out of space. And I list all these here. 2 times 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. And last but not least is 36. Two times 2 times 3 times 3. For some reason, something jumped on my screen and something moved over here in 36. So 2 times 2 is 4. 4 times 3 is 12, and 12 times 3 is 36. So if you look at these, the greatest common factor are going to be the numbers that all three have in common. You see a set of 2's right here that they all have, and another set of 2's that they all have right here. So the GCF, and this is the second way to do it, is going to be 2 times 2, which equals 4. And that is the way that you would find the greatest common factor of 3 numbers. So again, if the numbers are larger, it may be better for you to do a factor tree. Or if not, if it's easier for you to list them, you can go ahead and list them. You can do either one, okay? So I thank you for watching. I thank you for sharing this out. You all have an awesome, awesome day, and I will see you tomorrow. Take care. Have a great one. Bye-bye.